Welcome to Amar Rashid online math class. We have an identity on the board that we want to prove here. And the question says, prove the identity 1 plus sine x over cos x plus cos x over 1 plus sine x, which is identical to 2 over cos x. Mathematically, this one is trying to say that the left-hand side is just the same as the right-hand side. For example, if you choose x to be 60 degrees, and wherever we see x, we insert 60 degrees, we are going to have two equal sides after the whole process. So if x is replaced, we write 60 instead. Everywhere we see x, also on the right-hand side, both the right-hand side and the left-hand side, we are going to have equal sides. So this is telling us that this is what identical to this one on the right-hand side. So to prove an identity, we have three ways. Each of the three ways is correct. You consider the left-hand side, you solve, you simplify the left-hand side, but your answer must be what you have on the right-hand side. Or you consider the right-hand side, you simplify the right-hand side, but your answer must be what we have, or the left-hand side. But the simplest of them all is what? When you solve both sides simultaneously. But in the end, the two sides must be the same. All right. So now we want to show that the left-hand side is identical to the right-hand side. But the way the right-hand side appears, it will be that tedious or complicating in order to simplify this to get what we have on the left-hand side. But considering the left-hand side could be very much better. Okay, so we say, let us say solution here. Let us consider the left-hand side. Let us consider what? The left-hand side. What do we have on the left-hand side? We have 1 plus sine x over cos x plus cos x divided by 1 plus sine x. This is what we are given on the left hand side. So we want to simplify this one. We must simplify this one in order to get what we have on the right hand side. So what we do here is, let us try to find the LCM. The LCM of the two denominators, we can simply consider what? The product of the denominators. So we say cos x multiplied by 1 plus sine x. Okay, so cos x into the LCM simply means cos x takes away cos x, leaving 1 plus sine x. 1 plus sine x multiplied by 1 plus sine x. We have 1 plus sine x multiplied by 1 plus sine x. This takes away this, leaving this. This multiplied by this is what we have here. So we continue. 1 plus sine x into the LCM simply means this one takes away its kind, leaving cos x. Cos x multiplied by cos x, we have, mind you, we have plus. This takes away this, leaving this one. Cos x times cos x, we have cos squared x. Okay, so what do we do now? We expand. So 1 multiplied by 1, we have 1. 1 multiplied by sine x, we have plus here. 1 multiplied by sine x, we have sine x. So we are done with 1 multiplying every value here. Now it is time for sine x. Sine x times 1 is sine x. Plus multiplied by plus is plus. Sine x times sine x is sine squared x. Then here is plus cos squared x. So everything is divided by cos x multiplied by 1 plus sine x. So here we are now. When we consider the numerator, we keep going. This is 1 plus sine x plus sine x is 2 sine x. So here is sine square x plus cos square x. What is sine square x plus cos square x? It is what? 1. So this will give us 1. So we divide by cos x multiply by 1 plus sine x. 1 plus sine x. This is what we have. So 1 plus 1 is 2 plus 2 sine x. So this is what? Cos x multiplied by 1 plus sine x. So at the top there is a common factor. That is 2. 2 is common at the two terms. So we factor 2. So 2 into 2 here is 1. Then 2 takes away 2, leaving what? Sine x. We divide by cos x multiplied by 1 plus sine x. So at the top is one term, at the bottom is one term. So this one is with a factor of 1 plus sine x. This is also with a factor of 1 plus sine x, which are just the same. So we cancel them. So we are left with 2 divided by cos x. So therefore, we've proved that the left hand side is identical to the right hand side, because when we considered the left hand side and we simplified it, we are able to get what we have on the right hand side. So thank you for watching. Don't forget to like and share the video. Bye bye.